Hello everyone and welcome back. Today I will be teaching you derivatives of trigonometric functions. Many of you will recall your pre-cal days of memorizing trig identities. While this lesson is not too far from that. I'm not going to go into detailed proofs because that's going to take a lot of time, so you just need to memorize a few of the trig derivatives and accept what I say. And this is actually, just for fun fact, the second time that I'm doing this video because the last time I did it I screwed up on my last shot. I wrote secant x without the c. Okay. So let's go on. So the first trig rule that you need to memorize is the derivative of sine of x equals cosine of x, right? And next, you'll need to know that the derivative of cosine of x, ooh, having a bit of trouble with focus here, right? The derivative of cosine of x equals negative sine of x. From here you can see that a pattern rises, right? The derivative of sine of x is cosine of x, whose derivative is negative sine of x, whose derivative is negative cosine of x, whose derivative is back to sine of x, right? It's a four-step process, and I guarantee that this will that you will see it either on Mr. Wilson's test or in your homework. I think I may have screwed you guys up for that because now Mr. Wilson's not going to test you, but oh well. He did for us, I think. So, alright, so let's do example 1, right, to sort of reaffirm your understanding of differentiation rules, right? So, the okay, there are two examples. So the first example asks you to differentiate y equals x squared times sine of x, right? So you have dy dx. You use a product rule like you learned in the previous video, right? You have u dv, so you have the first times the derivative of the second plus v du, so you have the second term times the derivative of the first term, right? You're left with x squared times the derivative of sine of x, which is right here, cosine of x, right? Cosine of x. Plus sine of x, sorry, times 2x, right? And this is what your derivative is. You can't simplify it any further, so just leave it like that, right? I guess you could pull out an x, but we're not going to bother to do that right now. So next we move on to b. B is an example of the quotient rule, so you're going to have to use a quotient rule, right? You do du dx equals low d high, right? You have the low, or the denominator, low, times the derivative of the high, minus high cosine of x d low d dx of the numerator, all of that over low squared, 1 minus sine of x squared. Okay, so now we're going to have to simplify this entire equation. So you have 1 minus sine of x, right? A derivative of cosine of x, as you saw here, is negative sine of x, so negative sine of x minus cosine of x times the derivative of 1 minus sine x, and that's just 0 minus cosine of x, because the derivative of 1 is 0 and the derivative of negative sine of x is negative cosine of x, right? And once again, stick the entire thing over 1 minus sine x squared, right? Okay. So now you expand. Now you're left with negative sine of x plus sine x squared, right? Plus cosine x squared, right, from here. Okay. And you put all of that over 1 minus sine of x squared again. But you should know that the that sine squared of x plus cosine squared of x, sorry, I didn't mean to write that, is equal to 1, right? This entire part is equal to positive 1, right? So now you're left with 1 minus sine of x over 1 minus sine of x squared, which of course equals 1 over 1 minus sine of x. Okay. Now most of them will, so most of the trig identities or trig differentiation problems in your workbook or in your homework will work out fairly well because, you know, they've been designed to they've been designed to differentiate well. So you might be able to see identities like this or your other two identities, and that might really aid you in doing your questions. So let's move on to talk about the derivatives of other basic trigonometric functions. Because sine x and cosine x are differentiable functions of x, they're related functions, which are tangent of x, secant of x, cotangent of x, and cosecant of x, are differentiable at every value of x for which sine and cosine are defined, right? Their derivatives are given by the following formulas, which I have right here, okay? And I'm just going to pause this frame for a few seconds, let you either pause the screen or here, it's not going to help. So yeah, you can pause the screen and just look at it for a while, right? Okay, now we're going to do a question, example number 5 from your textbook. And it asks us to find y with 2 apostrophes. That's read as the second derivative, or y double prime, right? And we're supposed to find the second derivative of a trigonometric derivative, right? And so you would treat the second derivative, you would first take your first derivative, and then you would take it again, right? As if your first derivative is your position function and you're taking that derivative again. So you have y equals secant of x, right? So y prime should equal secant of x tangent of x, right? Right here. That's given right here, right? That's your first derivative. Then you're going to take your derivative again, right? And then you're left, so now you're left with a derivative of secant x tangent x, right? You would use a product rule. So now this would equal u, right, dv plus v du. Okay, and you would come up with secant of x times secant square of x, secant square x, right? That's given right here, plus tangent of x times the derivative of secant of x is secant x tangent x, right? So secant x tangent x. So in the end, you're left with secant cubed of x plus secant x, haha, I got it right this time, times tangent squared of x.